Major discovery of the year. Throughout history, humanity has been fascinated by the vastness of the universe. Countless scientists and philosophers have pondered about the size of the universe and how old it has existed, yet no definitive answers have emerged. Thanks to the remarkable advancements in technology, we now have the ability to gain some insight into these mysteries. Recently, NASA announced that scientists, aided by the iconic James Webb Telescope, have stumbled upon the largest structure ever observed. What is this gigantic structure, and how did it come to be part of our universe? What terrifying truth does this discovery tell us about the cosmos? Join us as we unravel how the James Webb Telescope just discovered the largest thing in the entire universe. The universe is teeming with colossal objects and structures scattered across galaxies and planets. Take, for instance, our moon, a behemoth celestial body with a diameter of around 3,474 kilometers. However, when compared to our home planet Earth, which boasts a diameter of 12,742 kilometers, the moon appears comparatively small. If we were to further compare Earth to the largest planet in our solar system, Jupiter, Earth would seem no larger than a ping-pong ball in comparison to Jupiter's soccer ball-like dimensions, with a diameter of approximately 140,000 kilometers. But even Jupiter, the giant of our solar system, is overshadowed by the colossal planet HD 10546b. This immense celestial body, which is 7 times larger than Jupiter, has a total diameter of 986,000 kilometers. Just envision the Earth in proximity to this cosmic monster. It would be utterly dwarfed. However, even the largest known planet in the universe pales in comparison to the sheer size of our Sun, which spans a staggering 1,392 million kilometers. And yet, our Sun itself would appear very small when placed next to the largest star ever discovered, Stephenson 218. For centuries, these astronomical dimensions have served as the framework for understanding the cosmos and the objects that have existed and still exist within it. However, recent events have sparked intense debate within the scientific community. The James Webb Telescope, one of the most powerful instruments for space exploration, has unveiled a gigantic structure in our universe that surpasses all expectations in terms of its massiveness. This discovery has ignited a bout of questions regarding its origin and has even led some to speculate about the potential involvement of extraterrestrial beings in its creation. Keep watching as we will explore the nature of this massive structure, its possible origin, and the implication of its existence. But it's important to first understand the instrument behind this terrifying discovery. The James Webb Space Telescope, JWST, is an astronomical marvel designed to surpass its predecessor, the Hubble Space Telescope, in its ability to explore the cosmos. What sets the JWST apart is its remarkable proficiency in observing the universe in infrared light, enabling it to penetrate dust and capture the faintest and most distant celestial objects that were previously beyond the reach of other telescopes. With a multitude of scientific objectives, the JWST aims to unravel the mysterious formation and evolution of galaxies, peer into the depths of the early universe, delve into the atmospheres of exoplanets, and investigate the intricate processes behind star and planetary system formation. At the heart of the James Webb Space Telescope lies its most striking feature, a colossal primary mirror measuring 6.5 meters, 21 feet, in diameter, comprised of 18 hexagonal segments. Let us delve into some of the breathtaking discoveries made by the James Webb Space Telescope thus far. While astronomers had initially detected exoplanets in the 1990s by observing the slight dimming of a star when a planet passed in front of it, the JWST has revolutionized exoplanet observation. Armed with advanced instruments, this remarkable telescope can directly capture images of exoplanets by skillfully blocking out the overwhelming light emitted by their host stars. Within a year of its launch, the Webb telescope achieved a historic milestone by capturing its first direct image of an exoplanet, known as HIP 65426b. This gas giant planet resides a staggering 100 times farther from its star than Earth does from the Sun. Employing multiple filters and cameras, the JWST skillfully captured images of this colossal planet, which were then artfully combined to form a composite image. These awe-inspiring discoveries not only demonstrate the remarkable capabilities of the Webb telescope, but also profoundly impact the field of astronomy. HIP 65426b holds particular significance due to its prodigious size, approximately 12 times the mass of Jupiter, and its considerable distance from its star, which facilitated its capture. However, the implications of directly imaging exoplanets extend far beyond visual allure. These images provide crucial insights into the origins of our universe and the tantalizing possibility of life beyond our solar system. They offer glimpses into the formation of planets and the composition of exoplanet atmospheres. Armed with these astounding revelations, scientists are poised to uncover habitable exoplanets, a long-standing aspiration in the field of astronomy. While the prevalence of habitable exoplanets remains a topic of ongoing investigation, the observation capabilities of the Webb telescope position it at the forefront of groundbreaking discoveries in this vast cosmic landscape. The images transmitted by the James Webb Space Telescope have revolutionized our understanding of the universe. These awe-inspiring visuals unveil a tapestry of stars and galaxies, with older galaxies appearing in reddish and darker hues. Teams of dedicated researchers swiftly set to work analyzing these images, employing cutting-edge computer technologies to extract a wealth of information from each luminous point. By scrutinizing the age of the light, identifying the elements present, calculating galactic velocities, and estimating stellar populations, scientists have unlocked a treasure trove of knowledge. However, the latest discovery made by the James Webb Telescope has left experts concerned, as it has the capacity to shatter some of our perceptions of the observable universe and extraterrestrials. How did previous search for life in space set the stage for this shocking discovery? The question of whether we are alone in the universe has fascinated humanity for ages. When we look up at the night sky, we see countless celestial bodies sparkling in the firmament. It begs the question, is it possible that Earth is the only planet harboring life? Despite the discovery of over 5,100 exoplanets in nearly 3,800 systems, we have yet to find another planet unequivocally categorized as habitable. The vast distances between us and these extrasolar worlds pose a significant challenge for precise analysis. However, our closest cosmic neighbor, Proxima Centauri b, presents a different scenario. Proxima Centauri b, located only 4.2 light-years away, was first detected in the summer of 2016 using the radial velocity method. It quickly became known as a potential cosmic twin of Earth. This exoplanet orbits its host star, Proxima Centauri, within the habitable zone. In the world of astronomers, the habitable zone refers to the distance between a celestial body and its parent star where water can exist in a liquid state. Liquid water is a fundamental prerequisite for the development of Earth-like life. Proxima Centauri b has an Earth Similarity Index, ESI, of 0.87, indicating its similarity to our planet. However, the question of whether life is possible on Proxima Centauri b, or whether it has already developed there, is not easily answered. Our current knowledge about this extrasolar neighbor is limited. What we do know is that recent spectrographic analyses suggest that Proxima Centauri b has approximately 1.17 times the mass of Earth. Additionally, the celestial body is believed to have a tidally locked rotation, meaning that it always presents the same side to its central star. This circumstance creates two distinct areas on the planet, a scorching hot day side constantly illuminated by the star and a bone-chillingly cold night side plunged into perpetual darkness. The estimated equilibrium temperature of the planet is around -38 degrees Fahrenheit. However, the presence of a dense atmosphere could significantly increase the surface temperature due to the natural greenhouse effect. Furthermore, the claim that Proxima Centauri b could host liquid water must be approached with caution, as the simulated orbital parameters and atmospheric composition that led to this result may not accurately reflect reality. Despite the spatial division into extreme areas, Proxima Centauri b still holds the potential for life to exist in a narrow band between the two sides. In this region, temperatures could allow for the development of life, and perhaps hypothetical inhabitants have evolved from simple single-celled organisms to highly advanced species over time. If this scenario is indeed the case, traces of such a civilization would likely be visible from our vantage point on Earth. In December 2020, an exciting discovery was announced, adding to the intrigue surrounding Proxima Centauri b. Some experts interpreted a mysterious radio signal as an artificially generated communication. The source of the signal could potentially be located within the realms of Proxima Centauri. Originally, researchers were studying the host star for signs of flares and their effects on surrounding planets using the Parkes Radio Telescope in Australia. During the analysis of the collected data, Shane Smith, and in turn with the Search for Extraterrestrial Intelligence (SETI) program, stumbled upon a conspicuous signal at a frequency of precisely 982.002 MHz. This signal, known as Breakthrough Listen Candidate 1, BLC-1, became an official candidate for an extraterrestrial radio transmission. Additionally, other experts identified a bright, long-lasting optical flare accompanied by intense coherent radio bursts in the Proxima Centauri system during the same period. However, the background of the signal still needs to be conclusively determined before BLC-1 can be confirmed as the technical signature of an extraterrestrial species. Further observations and detections are necessary to establish its origin beyond doubt. Let us consider the possibility that life on Proxima Centauri b has indeed flourished and evolved into a technologically advanced civilization. It would not be unreasonable to speculate that the inhabitants of this exoplanet have dedicated themselves to illuminating the dark night side of their world using artificial lights. Avi Loeb, an Israeli physicist, has been actively exploring new methods to uncover the presence of extraterrestrial neighbors. In collaboration with Elisa Tabor of Stanford University, Loeb published a study titled Detectability of Artificial Light on Proxima Centauri b. The study suggests that the hypothetical species on the exoplanet might utilize a lighting technology similar to terrestrial LEDs. They propose that if the artificially illuminated night side reaches just 5% of the brightness of the day side, the James Webb Space Telescope would have an 85% probability of detecting it. The more intense the artificial illumination, the higher the chances of detection. For comparison, the artificial illumination on Earth amounts to a mere 0.001% of the reflected sunlight. Therefore, the lights on Proxima Centauri b would need to be significantly brighter to be detectable. While these findings and speculations are intriguing, it is important to note that they are based on limited information and theoretical models. Outside the fascinating Proxima Centauri b, there is something equally interesting to consider. Black holes have captivated scientists ever since Albert Einstein predicted their existence in his theory of general relativity. These cosmic behemoths, with their intense gravitational pull, continue to mesmerize us with their mysterious nature. They defy the laws of physics in ways that baffle even the brightest minds. Surprisingly, recent observations made by the James Webb Telescope have challenged our previous assumptions about black holes. Traditionally, it was believed that black holes formed from the collapse of massive stars at the end of their life cycle, creating a point in space where gravity becomes infinitely strong. However, the discoveries made by the James Webb Telescope have turned this understanding on its head. The telescope has revealed that black holes were more abundant and massive in the early universe than we originally thought. This finding suggests that galaxies containing black holes must have existed even before the Big Bang. This raises intriguing questions about the age of our universe and the formation of these enigmatic cosmic objects. In addition to challenging our understanding of black holes, the James Webb Space Telescope has also uncovered 6 galaxies that provide a glimpse into the diversity and complexity of the universe. These galaxies are like a vibrant cosmic dance, showcasing the breathtaking beauty of our cosmos. However, amidst this beauty, black holes emerge as voracious monsters, devouring everything around them with their unimaginable gravitational forces. If black holes indeed originated from dead stars that grew in size by consuming matter or merging with other black holes, it would have taken millions or even billions of years for them to reach their current enormity. Here's where it gets intriguing. The discovered galaxies existed approximately 13.6 billion years ago, which implies that the Big Bang should have occurred 200 million years before the existence of these galaxies. This inconsistency challenges not only our understanding of black holes, but also our knowledge of star and galaxy formation. It shakes the foundations of the prevailing Big Bang theory and leaves scientists anxious about what this means for the future of our universe. Now, let's delve into what the remarkable James Webb Telescope has in store for us as we embark on the 2024 era of space exploration. What was the recent discovery by the James Space Telescope? And why is it a big deal? The James Webb Space Telescope stands as an extraordinary triumph of modern technology, poised to revolutionize our understanding of the cosmos. Its awe-inspiring imagery carries us on a mesmerizing journey through the depths of time, unveiling celestial wonders that defy our expectations. Among the initial images shared by NASA with international research teams and an enthralled audience on Earth, the Deep Field image captivated viewers with its awe-inspiring display of countless galaxies and clusters, as well as stars in our immediate cosmic vicinity. Promptly seizing the opportunity presented by the remarkable observing capabilities of the James Webb, astronomers eagerly delved deeper into space than ever before. In the ensuing weeks, reports overflowed with news of the detection of the oldest galaxy known to humankind, situated tantalizingly close to the momentous event of the Big Bang. It is conceivable that within these distant galaxies, we may uncover vital clues that shed light on the very origins of our universe. Researchers ascertain the distance and age of galaxies through the utilization of two primary metrics, redshift and the speed of light. In the arresting deep field image, the luminous or bluish objects discernible to us are celestial bodies that lie comparatively proximate to Earth. Their light has traveled a relatively short distance of merely a few hundred years before reaching the observation mirrors of the James Webb Telescope.